8 or 9 years. And then I am a manager who gets plenty of coding as his task. So I code a lot. So what happened is I needed to move into machine learning. So when I wanted to move into machine learning, the things I did was I discovered some small interventions into my existing application. So it wasn't like I was building a Skynet in Terminator, or it was not even, you have watched the movie this 2.0, right? So how many of you did watch it? I watched it too. So there was this scientist who created a robot. He created a machine that could learn. And even that machine produced another one, the 3.0 was riding the pigeon, right? So don't think about that. It are the solutions that would require you to be equipped with so much of statistics, neural networks, mathematics, and so on. So when I started from C# into machine learning, the thing that I did was I started doing small things. So today I want to share with you the same. So I'll move on with my slides now. So what is the agenda today? The agenda today is to talk about the movie 2.0. Do you want to talk about it? I don't want to talk about it because I didn't like the movie. Okay, so let's go into our agenda for today. So the main agenda, what I have kept as a tagline over there is, I want to break your barriers into machine learning. At the end of the session, I want to make sure that you get inspired, you have that knowledge, so that you can go back home and then start creating some machine learning solutions. What I say is, machine learning is not that hard, but at the same time, I would say it isn't that easy as well. So let's dive into machine learning and see how we can build the solutions. So my primary focus will be about inspiring you and giving you knowledge to build solutions. So that is how I am going. I'm not talking about neural networks, I'm not talking about what is machine learning and things, but the main thing I am talking about is how can I inspire you to get into machine learning, or how I actually did. That is what I'm going to share. Okay, I'm Raj Gautam. I flew here from Kathmandu, and I have been working in C# for a lot of time, and then I worked with USAID as an application and database specialist. So from there, I started getting interested into this machine learning things with data and all. So currently, I'm also doing my MSc IT in data science itself. Okay. So the first question that I want to ask is, I had a picture in the background, but it isn't over there. I'll fix it on another slide. So if you need machine learning, do you need machine learning? Everybody needs machine learning. So the picture back in this background was of a nail which was being used by a screwdriver, and in another bolt, hammer was being hit. So the first thing that you need to know is, if you need machine learning, when to use machine learning. So the one line statement or the answer for this would be, if you have a very hard time coding that solution, that is when you use machine learning. So for a simple example, you are over there, and if you just want to find out how many times I do my hand like this, you don't need machine learning for that. But if I carried this bottle from here to Delhi, and then I went to Kathmandu, and then I went to my home, and if this bottle wants to know in what temperature, how many times I sip the water, or if in morning I was having more water, or in daytime. So now you have so many of conditions to look into, and then find a solution, or you need to find the answer. So at that time you will be using machine learning. So one of my clients comes to me, and then he says, okay Dev, I need machine learning to be integrated into my human resource system. And then I asked him, so what is the problem? So he tells me that he wants to find out which employees were the most irregular on Fridays and Mondays. But that is just a thing about a simple SQL query, right? I can do select asterisk from my database where I will put a condition. So that is not the type of problem that you need machine learning. But if he had come to me and asked me, Deb, I need to predict who is gonna not come on next Friday. Or if he had asked me, find me the list of employees who are likely not to come on Monday. So that is when I need machine learning. Because I have this so many much factors that I need to integrate and find the right answer. So the first thing that you should keep in your mind before doing anything is if you really need machine learning. So I have written a one liner over there. It is needed for tasks that are too complex for humans to code. I mean, you will go into a rows of if and else doing all those things. So at that time, we need machine learning. So moving on, what are the type of problems that can be solved by machine learning? You have an enterprise, you want to forecast the sales for next winter. That is when you need machine learning. The other thing is you want to classify if a disease is a cancer or not a cancer. We called it classification, that is single classification. There is multi-class classification into there. I don't want to get into that details. But if you have a peculiar answer which your data can answer, then that is when you use machine learning. So another thing is if you want to find out if an email is a spam or not, that is when you need machine learning. So you need to have a question that can be answered with data in terms of numeric form, or it can be yes or no as well in terms of classification. So you need to have a problem that fits into this domain, and then only there is a use of machine learning. If there is a simple application which you can do with if, else and switch cases, then that is not where we do machine learning. That will be overdue. So the first thing that you need to ask yourself is if you need machine learning for this particular problem. Moving on. So the first example I have written over there is of a reinforcement learning. So this is basically like there is a machine that does the mistake and then learns from it. So if you have some kind of this solution, you can also use machine learning. Suppose if you want to make a chess player game. So suppose when the opponent wins the chess player, that is a machine, so it can learn how the opponent made his move. So if you have that type of solutions as well, you can use machine learning. And then the other one is also very important. You have heard of deep learning, right? Yes, so you have heard of deep learning. So the last example is somehow related with deep learning. I mean, you have a huge tons of data in your databases. You have it in file system, you have it in SQL database, MySQL, PostGRE, or any other database, Vertica, or any other database you could think of. So now what your solution does is it finds the pattern. So say I didn't wear a blazer, right? Every other speaker was wearing a blazer. So take Bhubaneswar has the data for like last 50 years that says which the speaker and he wore a blazer or not. So you keep on collecting all those data, and then what happens is a kind of pattern emerges. So this deep learning thing, you look into the patterns of data. I mean the data speak of themselves. So you cluster the data. We use clustering algorithms for this. So what happens is all the data that is similar to each other becomes one cluster. And then we can know we can make the predictions out of that. You have heard the example of movie. So a guy who likes the Terminator also likes Robot 2.0. So if you want to find this kind of association in between, so that is when you need machine learning. So it's not about there is a problem which you can solve it via SQL query, and then you will be using machine learning. So that won't work. So the first part of mind section as we are going is to make you aware about the problems that can be solved by machine learning. Yes, please.
So my question is it something that solve my probability questions?
Okay.
of mathematics.
Okay. So I got one question, but I think I might minimize the question a bit because I have a lot of slides to go. So yes, it does. It tells you the answer for you are doing a probability into something, then it will tell you the answer if it is likely to occur or not. So I also have the slides at the last of my section where I will associate statistics with machine learning. So I'll come into that. So where is this machine learning being used? Actually, machine learning is a subset of artificial intelligence, right? So if you have a robot or if you have a car, whenever we hear this word machine learning, the first things that comes into our mind is self-driving car and robots, right? But there are so many areas that machine learning is being used. And whenever we see machine learning or AI being associated with robots and self-driving car, what we think is, oh, too much neural network, too much statistics, too much algebra, too much algorithms, and then we get frightened to develop the solutions. But it's not that hard. I'm going to show you some demo. It's very simple, but it's not that easy as well. I'll go into that at the last part of my slides. Okay, so machine learning is being using in chatbots, NLP, natural language processing. Everybody has heard of that, right? So I go and say hi, how are you, and then it understands the same thing and answers me back. So chatbot is just like an engine above NLP. If you don't have NLP, then there is no chatbot. So we need to kind of dig deep into the things that how the solution is working. But you can say that machine learning is being used everywhere. It is in robots, it is in self-driving cars, it is in a recommendation engine, right? If I buy something and then there is a recommendation, if I buy shoes, then there is a recommendation to buy socks. But a true solution is doesn't work that way. For example, I'll give a classic example. So in US, they had this machine learning solutions in a supermarket. So what they find is in weekends, the baby diaper sales was increasing, and they tried to find out why. So the reason was mostly in the weekends, husbands were supposed to go for shopping. Okay, sorry, the sales of the beers were increasing. So whenever the husband went for a shopping, they used to grab a beer. They used to buy the diaper, but they used to grab a beer. So after that, what that department store did was they put a diapers and beer at the same place so that it would be easy. So there is this type of example that data can give you an insight about. So if you are talking about, if you are looking to find such type of solutions, then that is when you need machine learning. Okay, so it is being used in security, physical security as well. Say we are this much of people and then the machine learning finds out who is actually dangerous. Maybe machine learning might find me as a dangerous person in this crowd. So it's also being used in bots, the automatic answers. It's also been using in self-driving cars. It is also being used in agriculture, weather forecasting. So there are a lot of areas that machine learning is being used. I have tried to actually list some of them. So I think you already are familiar with the applications of machine learning. So I'll move further. So one example I would like to discuss about is money laundering detection and fraud. Suppose you have an application that lends credit, or suppose you are working in a bank and you want to find the person who is likely not to pay you back. So that is when we do machine learning. That is when it helps. So these are the basically types of questions that you can ask and get the answers back from the machine learning. So moving on, data. Is your data ready for machine learning? You have 5 text files with the speaker's data, wearing blazer or not, and you are trying to imply machine learning, then that is not going to work. You need to have a huge data. So how much big? that is a question that nobody can answer. I mean, like, it should be big, but we don't know if it is terabyte, gigabyte, kilobyte. It depends upon the problem. So, but you can make a mind of yourself that it should be big. I mean, it should be at least big. You should say that it's big. So that is the first thing. The next thing is it should be relevant. Suppose you are trying to predict the life expectancy. That would mean, so you are trying to predict how many years people in Bhubaneswar live in average. You are trying to predict, or you have the data and then you are trying to predict a guy's age when he will die. So in that case, you need to have the climate data, maybe the pollution index, or the nutrition status of that guy. So the data should be related. I mean, if I have to find the expectancy, and then I have the prices of the vegetable, then that is not going to work. But if I have a data about the toxic materials used in the vegetable that the guy is consuming, then that is something I am interested about. So your data should be relevant. The third is connected. You can't have, like, suppose you are trying to forecast the weather and you don't have the weather data for 10 years continuously. That is not going to work in machine learning, because that will be wrong. Machine learning are basically predictions. So we hear that word, right? Garbage in, garbage out, from the yesteryears of our school. That means if we have a bad data, then the prediction is also going to be bad. So the data should be connected. It should be accurate. Means it should not be wrong. It should be used, and it should be relevant. I mean, you could link it with the predictions that you are making, and the only 5 minutes. Oh my god. Okay, I might take 5 more minutes. So now, have you understood about the types of problem that you can solve with machine learning? Okay. So now let's start. How can you start developing the solutions in the machine learning? So I have two demos. So the first thing that you should get into your mind is, you don't need to be a statistician, mathematician. You don't need to know all of the algebra and the algorithms to start building the solutions into machine learning. So don't think very big, think small. For example, let me ask you the type of applications that you are working on. Any developer working in any solutions? Yeah. Sorry. Okay. Okay. You are using classification for that. If his tone is right or not. Hmm. Okay. You have logistics. So what does that logistic do basically?
Yeah, basically they do booking couriers for that, for container or crate cargo. So
Okay.
yeah,
So he has a logistic management system. So let's say that he implements a machine learning to find out when likely his warehouse is going to be with more space, or what exact time or the trend is there when the warehouse gets full. So think solutions like this. Don't think that we are going to build Chitti 3.0. You go it very simple. And that is how we move on with machine learning. That is the same thing what I did. I built a recommender engine. It was very simple, but that is how I get into it. If I start building a very big thing, then my knowledge would not allow me to, for me to do that, because I am doing C sharp, I am doing PSP or something else, right? Okay, so let's move on. So, can you write JavaScript? Everybody can write JavaScript, right? I can also write but a little bit of JavaScript only. I'm not so fond of JavaScript technologies. So I have this demo. This is a very simple demo. It's like a 5 or 6 lines of code. So suppose I own a pet e-commerce. And what happens is, people go and see a dog, they like it, but they don't know if that is uh, German Shepherd or of some other breed, right? So what we want to do is, this e-commerce will now build a site and let user upload a picture, and then it will recommend the other dogs that they have, looking at their breed. Okay, so let me go into the solution. Okay, so I'll try to quickly explain the code, right? It's just few lines of code, and I also have the link over there. I'll give it to you back. I have the gist uploaded into GitHub, so it's not a problem. So what I'm doing here is, are you seeing it? Okay. So I have loaded here TensorFlow. This is a JavaScript library, machine learning library that works in browser. And then I have load a model over here called MobileNet. Okay. So after that, what I am doing is, all these are HTML JavaScript code to upload a picture. That's it. There is nothing beside this particular HTML that I have to build this solution, right? So what I will do is, demos. Okay, so suppose this is a home page for the pet shop. So this is the list of the dogs that I have the images of. So it is predicted right over here, right? This is beagle. So I'll change the dog. So this is standard poodle. Okay. See, right? So what I'm doing is, I'm using TensorFlow library of that is used in machine learning.net to actually predict the breed of the dogs. So what I can do is, I can go into database, select asterisk from dogs where breed equals to poodle. So that is how I can build the recommendation engine, right? So if you think about this small solutions into your applications, then you can start actually building the solutions. So I don't have time, so I'll kind of skip a bit of slides and then reach towards the end. So the other thing is, you can think of natural language processing and chatbot. Making chatbot is not that hard. If you go with wit.ai, or there is also a engine from Google, if you use that, then you can easily build chatbots. So that is how you can move on. So there is another thing called, as she said, they use cognitive APIs, right? Use. So cognitive APIs are basically APIs that you can call from your applications. So you can make a simple REST call to the service API, get back the results, and do the necessary in your applications. So you can start building machine learning solutions this way. So I had another demo over here, but I guess I'll skip that. So how does the machine learning work? Is that simple that I have shown? Does that work on only 5 lines of code? No, it doesn't. So how does machine learning work is, actually what I had used earlier is a trained model. I mean, they have trained this object to predict the dog. So you have to do the same with yourself. What I had in my another demo was spelling correction. Think about spelling correction in your application. That is very simple, right? But you can use machine learning to do that. So the thing is, you have to define your objectives, your questions. You have to gather your data, find the relevancy. You have to train the model. Okay? And then you have to apply the algorithms into that. So depends. If you want to classify if an email is a spam or not, you have to use classification algorithm. There is KNN, there is a naive base, there are a lot of all other algorithms that you need to know about to apply in different situations, right? So you need to learn about the algorithms after that. Okay, now I'll try to sum it up. So there is something called supervised learning. In supervised learning, what you have is, you have input data and you have output data. So you have all the data from last year, you have the sales, and you are trying to predict this year. That is supervised learning. There is another called unsupervised learning, where you only have data and then you cluster the data to find the patterns. That is how unsupervised learning works. And there is also reinforcement learning. In reinforcement learning, self-driving car are the most eminent examples. I mean, they do the mistakes and they learn from themselves. So that is how reinforcement learning works. So there are this list of algorithms that you need to know. If you really want to master the art, then all the algorithms, you need to know their applicability, when to use those particular algorithms. Now the next thing, I had told you earlier that I would tell you my story, right? So I am learning data science, or I am doing my masters in data science because I know all the algorithms, but I need to know it theoretically as well. I mean, if you have a set of data, you should be able to know if you are going to get a mean or a mode out of that, right? So if you want to move into machine learning, then you need to know algebra. For example, in this example, this is one gradient descent. Gradient descent is one of the most like famous thing in machine learning. It is one of the algorithm, right? The algebraic state of that is this expression. So to understand this, you need to know algebra. You need to know a bit of statistics. That is only you can build up bigger solutions. But you can start with the JavaScript that I did. So you don't need to be frightened about building the solutions. You just think of simple things. For example, if you have a cooperative system or a bank system, then you can find out who is the likely person not to pay the loan. So that is how you think. Small solutions, small things, integrate the API, and then start building. So you can go to WordPress and find F5 blogs. That is my blog. I have actually written a blog about the solution that I showed the example about. I also have some chatbots blog in there that will provide you end-to-end solutions. So my name is Raj Gautam. If you want to connect to me, you can connect to me on LinkedIn, Facebook, or everywhere you can get me. So that's all for today. Thank you very much.